Are you aware that starting in 2026, many existing boilers may face environmental compliance risks and could be penalized or required to retrofit if they fail to meet the new standards? Good day, ladies and gentlemen. Welcome back to another video on the DIVI channel. Today's topic is key considerations when selecting a boiler from 2026 onwards. As many of you know, the boiler is the heart of a factory. If the boiler stops, the entire plant stops. If it runs unstably, production becomes unstable. If it consumes too much energy, product costs rise. In many facilities, the boiler is also the largest source of emissions, especially when the flue gas system does not meet environmental standards. The risk is not only financial penalties. The real concern is production disruption and the loss of long-term operational stability. Today, I will focus on three key issues. 1. Environmental. 2. Steam production cost. 3. Boiler operational stability. Issue 1. Environmental compliance. From July 1st, 2025, QCVN 19:2024/BTNMT officially takes effect for new projects. Compared with previous regulations, several emission limits have been reduced by about 30 to 40%, especially for particulate matter and CO. As a result, technical requirements for new boiler systems are much stricter. More importantly, emission values must now be corrected to a reference oxygen concentration. This means that the approach of injecting additional air to dilute the flue gas will no longer be legally effective. If the combustion process is not optimal, CO will still be high. If the dust treatment system is ineffective, emissions will still exceed the limits. Therefore, from 2026 onward, boilers can no longer be built first and retrofitted with environmental systems later. The system must be properly designed from the start. Regarding technologies with stable combustion and good control, such as fluidized bed boilers burning biomass, or boilers using liquid and gaseous fuels like diesel, LPG, CNG, and LNG, have a clear advantage in meeting environmental standards when properly designed and controlled. For fixed-grade boilers that manually burn firewood, meeting the new standards will be very difficult without investing in a proper flue gas treatment system and strict fuel control. Electric boilers are also an option worth considering in areas with strict environmental requirements, as they do not produce direct emissions at the plant. Regarding dust treatment, the dust filtration system needs to be designed in multiple stages, depending on the boiler capacity and the plant location. It typically includes a coarse filtration stage, settling chamber, a cyclone stage for finer filtration, a fine particulate stage using bag filters or equivalent electrostatic dust collectors. In special cases, an additional wet treatment stage may be added downstream to further improve efficiency. Regarding fuel moisture directly affects the combustion temperature and the CO level. For many biomass technologies, fuel moisture should be kept as low as possible, typically below 40 to 45%, to ensure efficiency and emission control. If the moisture content is higher, the risk of increased CO formation and fuel consumption will rise significantly. Regarding control, the control system should be automated with linear fuel feeding and air adjustment according to load using PLC or SCADA. When the combustion process is properly adjusted, CO will remain within the controlled range, and the boiler efficiency will be maintained stably. Issue number 2, steam production cost. The purchase price of the boiler accounts for only a small portion of the total lifecycle cost of the system. Most of the cost lies in fuel and operation over the 10 to 15 years of operation. Liquid and gaseous fuels usually have a higher steam production cost due to their higher fuel prices. Under normal market conditions, imported coal and biomass fuels such as wood chips, rice husks, sawdust, cashew shells, etc., usually have significantly lower steam production costs. Biomass pellets have high uniformity, but their cost is typically at an intermediate level. The key point in optimizing costs is not choosing the cheapest type of fuel, but controlling the fuel quality and moisture content. Fuel that is not sprayed with water, not exposed to rain, and properly stored. That is the key to reducing consumption and stabilizing costs. Issue number 3, boiler stability. Boiler stability depends on 3 factors. The first is design. In DIVI's design, equipment is selected based on the principle of safety with reasonable redundancy. For example, if the boiler operates at 12 bar, the design pressure will be calculated at least 20% higher than the actual operating pressure. The second factor, equipment selection. Boiler valves and accessories are typically selected at PN25 or PN40, depending on location and operating temperature. The goal is not oversizing, but ensuring the equipment operates below allowable stress limits to improve durability and reduce long-term damage risks. The third factor, actual fuel conditions. Vietnam is a tropical country with hot, humid weather and frequent rainfall. Fuel moisture content is often higher than in temperate countries. Therefore, when importing boilers, it is important to discuss Vietnam's actual fuel characteristics with the supplier. A design suitable for dry fuel may not operate optimally under tropical conditions if it is not adjusted. 3 common fluidized bed boiler configurations. Currently, there are 3 main types on the market. 1. Water tube and fire tube combination boiler. 2. 2-drum water tube boiler. 3. Single drum water tube boiler. Basically, the combustion technology and flue gas treatment can be equivalent if designed properly. The difference lies in the heat exchange section and the boiler body structure. Fire tube boiler. Tubes are easier to replace, but the tubes need to be cleaned more frequently because the flue gas passes through the tubes. 2-drum boiler. The structure is robust, but when the convective tube bank is damaged, it usually has to be handled as a unit, and individual tubes cannot be replaced. Single drum water tube boiler. The water volume is smaller and the steam generation rate is faster, but it requires stricter control of water quality and blowdown. Each type has its own advantages and disadvantages. No type is absolutely better. What matters is suitability to the actual operating conditions. I have reviewed 3 main issues when selecting a boiler from 2026 onwards. 1. Environment must be addressed from the design stage. 2. Cost should be considered over the full life cycle. 3. Stability depends on design and actual fuel conditions. From 2026 onwards, selecting a boiler is not only a technical matter, it is a matter of risk management for the entire plant. If you do not want to manage all the technical, environmental, and legal risks of the boiler yourself, then models such as steam purchasing, operation leasing, or outsourcing boiler operation to a professional unit are options worth considering. Thank you for watching.